You randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample temperature is 162 degrees. You have a sample standard deviation, which is 10 degrees. Question says, construct a 95% confidence interval for population mean temperature of coffee sold. Guys, our goal is to construct confidence interval for population mean. It's not population proportion. Confidence interval for population mean, not proportion. So take a look at the board. Are we dealing with 6.1 or 6.2? Well, depending on if sigma is given or missing. Let's take a look at the question. Is sigma is population standard deviation. Is sigma given or not? Take a look at the question. Super important to read the question carefully. It says, hey, we have a sample and the temperature mean for the sample is 162 and sample standard deviation. There is no information about population standard deviation. It just says that, hey, sample standard deviation is 10, okay? So is sigma given? Nope, it's not given. So we're going to use 6.2 or the middle column. Okay, very good. 6.2. So what are the steps? Give me the steps. Now that we know that we are building the confidence interval for population mean, and we know that the sigma population ST is not given, step one is to find the point estimate. What is the point estimate? What is the sample mean? What is the sample mean? Let me read the question one more time. What is my sample mean? The sample mean is 162 degrees. Very good, I have that. I'm going to write it down here. It's 162 degrees. Step two. Well, in the second step, I need to find the confidence level. What is confidence level? What is the level of confidence that I'm working with? Go back to the question. Question says, hey, construct a 95% confidence interval. So my confidence level is 95%. 95% or 0.95. Very good. What is my next step? Step three. My step three, the third step is to find the critical value. Find critical value. Hey, am I finding ZC or TC? Which one? Is it a TC or is it a ZC? Guys, it's super important that we make a correct decision. If our decision is not correct, it's going to affect everything. Are we computing ZC or are we computing T sub C? Which one is that? Take a look at your board. In the middle column, in step three, we need to find the critical value, which is T sub C. Sigma is missing. We are not allowed to use ZC. We have to find TC. It is TC since sigma is missing. Super important. Use a different color, not a ZC. TC since sigma is missing. Okay, very good. So far, so good. But how do I compute T sub C? We have two options here. First, you can use your calculator. Go to second, vars, find inverse T. Okay, let me do that. As I go through the whole thing, let me show you how to find TC. Turn on your calculator. Okay. Let's see. Whatever it is, I have no idea. Second vars. And I'm going to go to inverse T. Okay. Let me select that. And then what do we have here? We need to enter some information. What is the area? Okay. Let me clear this. What is the area? First of all, the confidence level is given to me as 95%. Remember that. We need to enter the area as 1 minus C divided by 2. Okay, my C is 95%. So I have 1 minus 95%, 0.95. Don't forget to put point here, 0.95 divided by 2. It means that you have 5% over 2 or 0.025. So this guy is going to be 0.025. Next, I need to enter my degrees of freedom. What is DF? Degrees of freedom is n minus 1. But what is n? What is my sample size? Let me go back to the question. What is my sample size? I don't remember that. 16 coffee shops. So the sample size is 16. Okay, very good. Sample size is 16. So 16 minus 1 is 15. I'm going to enter 15 here and then go to paste to compute my value, which is, well, as you can see, you have negative 2.13, but remember that for a critical value, you're going to use a positive value. The margin of error must be positive. So T sub C or critical value is 2.13. Very good. So far we have the critical value. What is the next step? In my second column, I have step 4 as the margin of error. Margin of error. Do I have a formula for that? Yes. Margin of error, E, is equal to T sub C, the critical value that you found here, times S. What is S? S is sample standard deviation over square root of n. N is the sample size. So I calculated T sub C, which is 2.13. What is S? Well, what was S? I don't remember. I need to take a look at my question again. What is S? S is the sample standard deviation, which is 10 degrees. 10 degrees. 10 divided by square root of n. What is n? N is the sample size. Remember that sample size is 16. So let's do the computation. Let us compute this guy using our calculator and see what do we have here. The margin of error that we calculate is going to be about 5.3. So this is my margin of error. I found the margin of error to be 5.3. And what is my last step? Step 5. Confidence interval. It's going to be open parenthesis, x bar minus margin of error, comma, x bar plus the margin of error. Do I have this information? Yes, I have all of them. I know what x bar is, and I computed my margin of error, which is 5.3. I just need to enter all of these here. 162 minus 5.3, comma, 162 degrees plus 5.3 degrees. Approximately, it is 156.7, comma, 167.3. Okay, this is my confidence interval, but what's the meaning of that? What does it mean? Well, how do we interpret this? We're going to say that, hey, we are 95% confident that we are 95% confident that the mean temperature of the population is between 156.7 degrees and 167.3 degrees.